Okay. Can anybody put it in the WhatsApp group? Kindly join MS Teams. 1, 2, 3 students kindly put. Okay, for the others, I'll start the class. Okay, so kindly please put it in the MS Teams. Okay, I mean in the WhatsApp group, kindly please join MS Teams back. Okay, so we'll start. Has the recording started, students? Has the recording started?
Yes, sir.
Yes, sir.
Okay. Okay, students, we will be entering into module 5. Okay, that is unsupervised learning. Okay, so unsupervised learning, we will be mostly talking about clustering. Okay, so now introduction to unsupervised learning. Okay, now in supervised learning, what happens there? So for example, when the features x1, x2, x3, x4, x5 was given, okay, then you had a particular class label, right, where it is yes or no, okay, or 1 or 0 or true or fall or pass or fail, hot or cold, summer or winter. That is the target label was given. Then you applied the training set, testing set, then you try to predict whether using a test instance what it is actually there in the data set and what you are producing an output yes or no, and what is there in the target level. Okay, whether the both are matching or not, by calculating the errors, MSC. If it's a continuous values, we go payment for logistic regression. If it is a discrete value, we went for a classification problem. That is the target where the output was already known to us. Yes or no, students? Yes or no?
Yes, sir.
Yes,
Okay.
sir.
Yes, very good. Excellent. So, but in unsupervised learning students, there is no target level. We don't know what is the output. Neither we are interested in the output. We don't know whether the student will pass or fail. Okay, yes or no, 1 or 0, true or false, hot or cold. We are not interested. Whether we want to know also. Okay, there is no target label itself. But however, we do certain things slightly away from supervised learning. Now, what is that we do? We look for patterns. We look for similar people. We look for group of people. That is all boys, all girls, all gents, all students, all machine learning students, all computer Python students, all IoT students, all HODs, all school students, or all class 12 students, or class 12 economic students, or class 12 science students, or the people who drink only Coke, the people who drink only Sprite, the people who drink only Maza, the people who only watches cricket. That is the people who only watches cricket, okay, for an age, particular age, say for example, one age 1 to 10, the two small children. In that small children, only girls, only boys. Okay, the people who watches only football match. So what are we doing? We are grouping the people into particular categories, into clusters. Okay, that is what it is. This is one type. Another type is also if say for example, if Raj comes to the shop, Rajiv is most likely to also to come to a shop. If you buy a newspaper in the morning, you will buy milk also in the morning. If you take out the money from near next to the petrol bunk, you will most likely enter into the petrol bunk in the next 2 seconds. If you take out the money from the ATM from the restaurant, the most likely in the next 2 minutes you will enter into the restaurant. Or from a medical shop, if you take out the money from an ATM, the most likely you are going to enter into an ATM shop, medical shop. If you most likely to take out the money from the ATM next to the theater, the next minute, okay, you most likely you enter into the theater. So you're going to identify the patterns. Okay, so which route you travel through. Okay, so daily you start the bike, you go to the petrol bunk, you halt, then you go to a particular shop, you halt there, then you go to a next shop, you halt there, then you reach office. So this is your pattern. petrol bunk, have tea, okay, then have breakfast, then you go to office. Okay, so the day 1 you take out bike, day 2 you take out car, day 3 you take out bus, day 4 you go by train. So if I train if I see your pattern for a longer period of time, so which pattern you're following? So we are most likely to form some interesting structures in them. So clustering, we go for clustering. For grouping, clustering means what, students? Cluster. COVID cluster, no? Hey, don't go to that area. The cluster is formed. What do you mean by cluster? Don't go to that apartment. Okay, the cluster of people. There is a cluster being formed. That is some people who are having COVID-19. So clustering is a technique for finding similarity in the groups and data. Okay, it groups the data instance that are similar and near to each other in one cluster, and data instances that are different, far away from each other. That is, if you have two clusters, all boys in one cluster and all girls in one another cluster. Okay, so all boys will be, say for example, similar to each other, the features. So we put them into one cluster. The same way all girls, okay, into another cluster. Or all men and all women, or all school studying students, or our IT professionals, different clusters. Okay? Unsupervised learning here, they don't have a prior data instance. They don't have the target variable, like in case of supervised learning. Clustering is often considered synonymous with unsupervised learning. Okay? Clustering is with respect to unsupervised learning. So, IT students, swimmers, and cricketers. 3 clusters, 3 data points. Okay? Now, so what is clustering for? Say for example, students, if I want to have a pant, if I'm having a tailoring shop, okay, or say for example, if I have a clothing shop, if there might be 100 people, okay, to stitch a particular cloth for 100 different people of different sizes, it's going to be a very difficult job for me. It's going to be a really difficult job. So what I do is, okay, small, everybody, whoever it's a small, 3 to 4 years, or 8 to 10 years, or 12 to 14 years, or 18 to 20 years, or 20 to 23 years, or 25 to 28, or sizes in terms of jeans, 32 size, 34 size, 36 size, 38 size, hip size. Same way with t-shirts, okay, small, medium, large. I don't make, okay, according to the people, individual people. I just make small, medium, large. Whoever it fits it, let them take it. That is how, okay, the clothing industry runs in malls whenever you go. Tailor is different. That is with respect to personal. It's something like Ola car and a private car. So you go to a tailor, it's a private car. But when you go to an Ola car, it's for everybody, right? Or a vehicle, private government vehicle or a government rate. Yes. So the same way, so I built, okay, the t-shirt, I stitch the t-shirt based on small, medium and large size, okay, and it one fits for all. The same way, according to 32, 34, 38 jeans, you take it, you cut it, you do whatever it is, but it as far as it fits you. The same way, another one is where we go for a clustering concept is, say for example, students, have you ever wondered when you click on YouTube, okay, or when you click on any ad, say for example, a Facebook is going on, when you click on an ad, okay, the next time when you open the YouTube, okay, that particular YouTube video will be shown the related videos will be displayed based on that. Okay, on the Facebook, if you click on a particular link or some particular college, okay, say for example, if you are clicking on VIT, say for example, you are in 11th standard, okay, you are clicking on VIT. Okay, that's it. You have just clicked on VIT or we have visited the VIT website. That's all you have done. www.vit.ac.in or chennai.vit.ac.in. The next time you enter into YouTube, okay, you know what is the video will be shown to you? Okay, VIT video will be shown to you. Okay, about VIT. Okay, what are the things? Okay, everything will be shown about VIT. So that will be followed, okay, for the next 15, 20 days or 30 days or 40 days. Every time you enter into YouTube, the only thing what you have done is you have just entered through particular click, okay, some VIT website. But every time in the next time when you open, in between the videos watch, VAT video will be shown to you. How is that so? That is called as everything is linked through Gmail, and that is how we do Google advertisement. Okay, I am in admissions team. I do SEO. Okay, I have gone through the SEO training phase, and we take care of the SEO for Chennai VAT website. Okay, so we do the targeting audience. So what is the targeting audience? Okay, in Google Analytics, everything can be done. Okay, in Google Analytics, everything can be done. So you can target the age. I can check. Okay, I can check in India. Okay, in India, how many people are visiting VAT website? Okay, whose age is less than 18? Okay, whose age is less than 18, and okay, how many of them are boys, how many of them are girls, okay, and what is their interest, what is their interest, okay, what is their interest with respect to boys, what is their interest with respect to girls, okay, and what is their interest with respect to your parents also. And at times we also do the particular age analysis and income analysis. Because every record, okay, everything Gmail is having. From Gmail only we are seeing. That's it, nothing else. Okay, and from which region, from which city, from which area, and who is that boy or who is that girl also we can see. So how are we doing? Just by that particular student coming to that, clicking on to that particular VAT website, and we do analytics, and we pay crores and crores of rupees to Google, doing money for what? Advertisement. For YouTube, we spend crores on rupees. For Google, we spend crores or rupees. For advertisement, we spend crores of rupees. Okay, that is why we target the audience. I don't want to target a IT professional who's working at Infosys to come for VAT. No, we target based on the audience. So that is how the SEO industry works. Okay, so doing the target marketing. Okay, so example 3. Okay, given a collection of text documents, we want to organize them into the contents based on the similarity. So this is another part where PhD people do researches. Okay, PhDs. Given the similarities of the document. Okay, so clustering, the close of the clustering is to group the people of the similar kind. So Coca-Cola, those who drink Coca-Cola, those who drink Sprite, those who drink Pepsi, okay, those who drink Fanta. This is what we have done. Identifying such groups of clusters in an unsupervised learning, or else we can have people who are having COVID, people who are having dengue, people who are having malaria, people who are having, say for example, cholera, or people who are boys, people who are girls, people who are cricketers, and people who are swimmers. So I have given enough methodology for clustering. So cluster is represented by a single point called as a cluster, okay, or as a center head. The centroid is computed. Okay, we will see this based on the problems. Mean of all the data points in the cluster. Then we draw the decision boundary by the farthest point. We'll come back to it, no problem. That this slide we'll do work it in the problem. So clustering is a task of grouping a set of data points such that the data points in the same group are more similar. So it means what? If this is my cluster, that everybody in this cluster drinks Pepsi. So these are similar data points. Everybody drinks Coke. Everybody drinks Fanta. Everybody drinks Mirinda. Okay, so more similar to each other. So how are they similar? Because everybody has a similar taste. It groups the data instances that are similar to each other in one cluster, and the data instances in different, far away from each other. See, our goal, students, our goal is to, okay, intranet. Intranet means maximize. Okay, bring all the points closer to each other. Minimize all the points closer to each other, data points within the cluster, and maximize. This distance should be maximized. The distance between the two clusters should be maximized. A quality clustering is the distance between the two clusters should be maximized, and the points within the cluster should be minimized. The distance should be minimized. Getting the point? Hello, is everybody is able to see and listen and hear me clearly?
Yes, sir.
Okay, so what is natural grouping of these objects? Okay, so you have the thing. If I just show you this thing, will you be able to understand? No. Will you be able to understand? No, you cannot understand. Something is happening. You can say some cartoon character. But if I group them into the cluster, it gives you some information out of it. Okay, Simpsons family, school employees, females, males. Can you see? If you look at this, no information. Okay, but if you look at this, okay, so different things. Okay, you're clustering, you're grouping them. Okay, so two types of clustering. Partitional clustering and hierarchical clustering. We'll first enter into the partitioning clustering, construction of various partitions, and then evaluate them based on some criteria. Creating hierarchical objects, hierarchy, and then analyzing them based on some criteria. Okay, so you partition them. Can you see? You have partitioned them. And then analyzing it. Okay. So aspects of clustering, partition, and hierarchical. So clustering quality, as I just told you. Intercluster maximized, intra-cluster minimized. So within the cluster, our aim is to make sure these dots fall into as close as possible. And intercluster make sure that the difference between the people who drinks Pepsi and Coke, these two clusters are far away from each other. Okay, and the people who drinks Pepsi are very nearer to each other. So this is the quality clustering. Okay, so intercluster similarity is maximized, and you see, similarity is maximized, and intracluster similarity is minimized. So the features between the Pepsi and the people, okay, say for example the cricketers and swimmers, okay, their features should be maximized. Okay, there should be more dissimilarity among these two. Okay, and within the cricketers there should be more similarity. Okay, that's the point I'm going to make. Okay, so usually we will start with, there are different types of clustering and a partition. So we will start with k-means, then k-modes, and then we will see NNN. Okay, nearest neighboring cluster also. Hard and soft clustering. Hard clustering, each document belongs to one cluster. Soft clustering, a document can belong to more than one cluster. Okay, so makes more sense for applications like creating browsable hierarchies. So if you want to put a pair of sneakers into two clusters, sports and shoes. Yes, so if I have two clusters, okay, so sports and shoes. So sneakers belongs to sports and sneakers belongs to shoes also. So you can do with that soft clustering approach. Hard clustering, okay, one cluster, male means only males will be there. Females means only females will be there. Okay, but in general compartment, if you see a soft clustering example is, say for example, a bus or a train. Okay, train. If girls are there, they can enter into girls compartment, or else they can enter into general compartment. Both. Right? The same way with sneakers also. Okay, sneakers, you can put it in shoes as well as for sports also. So that's it. Okay, so now students, the first one, what we will be doing is, okay, we will be seeing k-means clustering. Okay, students, so directly I will enter into the problem, then I will come back to the algorithm, and then we will be seeing. Students, now k-means clustering. Okay, now k-means clustering means the k denotes how many clusters you want to create. Okay, how many clusters you want to create. So if the k value is 1 means you will create only one cluster and you will try to group them everything into one cluster. If k value is 2 means then you will try to create two clusters and then you will try to group the different data points into two clusters. If k is 3 means you will create three clusters, okay, and you will group them into three different clusters, the data points. So now students, okay, first I will explain you the problem. Once you are done with the problem, then if you see all these PPT, whatever I have written here, you will be able to understand Pakka. Okay, so students, I have 10 data points. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so 2 and 4, okay, x and y coordinates, okay, value, x value, y value, 2, 4, 2, 6, 5, 6, 4, 7, 8, 3, 6, 6, 5, 2, 5, 7, 6, 3, 4, 4. So what we have done is, what this diagram shows is, okay, I have plotting. x comma y coordinates. Okay, so 2 comma 4, then 2 comma 6, okay, then 4 comma 7, then 5 comma 6, okay, then 5 comma 6, then 5 comma 2, okay, then 5 comma 2, then 6 comma 6, 6 comma 3. So these are the 10 data points of what I have plotted on the graph. And then students, this is the cluster middle. This is the cluster middle, a centroid, a centroid. Okay, the middle data point. Now what we are doing is with one centroid. Can you see? With one centroid. Okay, now what we are doing is, students, I am coming up with 3 clusters randomly. Okay, I am creating 3 clusters randomly. So the value of k is 3. 3 clusters are created randomly, so the value of k is 3. If I am creating 4 clusters, k equal to 4. If I am creating 5 clusters, the value of k is 5. If I am creating 6 clusters, the value of k is 6. If I am creating 2 clusters, the value of k is 2. So it is called as k cluster. So this is the meaning of k. Now then means and clustering, I will tell you. What is the definition of mean and clustering? Okay, so clustering we know. Now what is the definition of mean? You will be able to understand later. So now what is the 3 clusters I am creating is, say for example, the points is 1, 5, 4, 1 and 8, 4. This is the points. 1, 5, random points. Random points. These are random points. 1, 5, 4, 1, 4, 1 and 8, 5. 8, 4. 8, 4. 3 clusters I am creating. Since the value of k is 3 random points of 3 clusters I am creating. Now what am I going to do, students? Now what am I going to do? I am going to take these data points and I am going to map these data points into one of those clusters. Okay, into one of these 3 clusters, into one of these 3 clusters by a particular computation process. I'm going to take the data points, shift the data points, vary the data points. Finally, in my end, okay, I will make sure the 10 data points fall into different clusters where it can fit the best. Where it can fit the best. Okay, accordingly, I will keep doing the process. Till here, everybody is able to understand. Till here, everybody is able to understand, students. Hello? Till here, everybody is able to understand? Quickly, please. Please reply, please. Till here, everybody is able to understand?
Yes, sir. Yes.
Okay, very good, students, very good. Okay, so now what am I going to do? I have taken k as 3 random clusters. Okay, so these 3 are my data points as I told you. So what is my cluster data points? 1, 5, 4, 1 and 8, 4 and 8, 4. Now students, kindly please listen. Okay, the process is same. So for the first 2 iterations I will tell you, other things are same. Okay, students. So I have my values, 10 values, and I have my 3 clusters and the data point is 3. Okay, these are my 3 seed points. So 1, 5, 4, 1 and 8, 4 are my 3 clusters. Cluster 1, 1, 5, cluster 2, 4, 5 and 8, 4. 1, 5, 4, 1 and 8, 4. Now students, now what I will do is, students, I will calculate each data point, okay, the distance between this cluster to this data point. Okay, then the distance between this cluster to this data point. Then the distance between this cluster to this data point using Euclidean distance. Using Euclidean distance. Okay, you can use various methodology, but for our entire machine learning course, we will stick to Euclidean distance, as simple as that. Okay, Euclidean distance. We will stick to Euclidean distance. Okay, so now, so the same thing, what we will do is, then I will take the second data point. Then I will calculate the distance between second data point to the first cluster, second data point to the second cluster, second data point to the third cluster. Then the third data point to the first cluster, distance between third data point to the second cluster, third data point to the third cluster. Then fourth data point to the first, fourth data point to the second cluster, fourth data point to the third cluster, fifth data point to the first cluster, fifth data point to the second cluster, fifth data point to the third cluster, and it goes to the 10th data point to the first cluster, 10th data point to the second cluster, and the 10th data point to the third cluster. So let's see. So if I do this process, what do I get? What do I get? Okay. So can you see? So I'll just explain for two things. Okay. See. So 2 minus 1. So 2 minus 1, which is 1 squared, plus 5 minus 1, which is 4 squared. So 4 squared is 16 plus 1, 17. So square root of 17. Okay. So 2, can you see? 1 minus 1. Okay, sorry. 1 minus 1, it is 0. So 1 minus 1, it is 0. And 5 minus, sorry, yeah, correct. It's 2 minus 1. Okay. So 2 minus 1, which is 1 squared. Okay. Plus 4 minus 5, again, which is 1 squared. So square root of 2, square root of 2, which is 1.41. Okay, the same way. Then 2 minus 4. Okay, 2 minus 4. So what is 2 minus 4? 2 squared. 2 squared. Plus 4 minus 1. 3 squared. 3 squared. Okay, so 4 squared plus 3 squared, 9, 10, 13, square root of 13. So what, which is 3.16. Then 8 minus 2, 6 squared, then 4 minus 4. So square root of 36, which is 6. Okay, so then you will be doing again 2 minus 1, the whole square. Then 6 minus 5, the whole square. Okay, then 2 minus 4, the whole square. Plus 6 minus 1, the whole square. Then 2 minus 8, the whole square. Plus 6 minus 4, the whole square. So again you get these three values. The same way you will be doing for 4 minus 1, the whole square, 3. Okay, then 4 minus 5, the whole square, 1. So then you take the square. Then 4 minus 4, 0. Then 4 minus 1, 3 squared, 9. Square root of 9. Then 4 minus 8, 4 squared. Then 4 minus, so 16. So 16 is 4. Okay, so then once you are done. So this particular table you have got. Is this table very clear to you? Is this table very clear to you, students? Is this table very clear to you? Hello? Is this table very clear to you till here?
Yes, sir.
Everybody? Here, please, everybody, please reply. I don't have time, please. Here, please reply. Yes.
Yes.
Okay. Now, students, after doing this process, you will check which has the minimum distance between 2, 4, 1, 5, cluster 1, 2, 4, 4, 1, or 2, 4, 8, 4. So this has minimum distance. So this data point 2, 4 belongs to cluster 1, belongs to cluster 1. The same way, 2, 6 belongs to cluster 1. Then 5, 6 belongs to cluster 3. Then 4, 7 belongs to cluster 1. Then 8, 3 belongs to cluster 3. Then 6, 6 belongs to cluster 2. Then 5, 2 belongs to cluster 1, cluster 2. 5, 7 belongs to cluster 3. 6, 3 belongs to cluster 3. Okay, and 4, 4 belongs to cluster 2. So that is what I have written here. We have written here. Okay, done. Now after doing this, the next step is, students, now we will be calculating the new centroid. Okay. For the first problem, for any problem, you will be calculating the new centroid. Okay, but after the second iteration, you will see has the data points moved from one cluster to another cluster. If the data points have not moved from one cluster to another cluster, you will stop the process. But if the data points have moved from one cluster to another cluster, again you will be calculating the new centroid, doing the same process again and again, Till when? Till the difference between the previous iteration and the current iteration, there is no shift between the data points. Okay, so now we are calculating the centroid. So how we are calculating the centroid is, take cluster 1. Take cluster 1. That is 2, this data point, this data point, this data point. These are the 3 cluster ones, right? So 4 plus 2 plus 2 is 8. 8 divided by 3 is 2.66. That is, I am taking the mean of it. Then 4 plus 6 plus 7, 17. 17 divided by 3 is 5.66. Okay, then you take cluster 2. Cluster 2 is what? Cluster 2 is what? Cluster 2 is what? Okay, this, that's it, right? This. So 5 and 4, 9. 9 divided by 2 is 4.5. Okay, so 6 divided by 2 is 3. This is cluster 2 centroid. So mean, I'm taking the mean of the clusters of the data points. Then cluster 3. The cluster 3 is what? So 5, 8, 6, 5 and 6. So 8 plus 5 plus whatever the values you get, you divide it by 4. Because there are 4 data points. And then 6 plus 3 plus 7 plus 3. Okay, 6, 6, 12, 18, 19. Okay, whatever may be the value you get. Okay, or 20, whatever the value you are getting. Okay, so how many clusters? 1, 2, 3, 4, 5. So 5 clusters. 6, 3. Okay, 6, 6, 3, 3 and 7. So which comes around 20, I think so. 25. Okay, so when you add this, you're getting 25. So 25 divided by 5 is 5. So now you have calculated 3 clusters. So now what am I going to do? I go for iteration 2. Iteration 2, my new centroid is 2.66, 5.66, 4.5, 3, 6 and 5. Can you see? 4.5, 3. Now again I calculate the same part. Okay, the distance between this and this, this and this. And distance between this and this, this and this. Distance between this and this and this and this. For all the 10 points. For all the 10 points. For all the 10 points. Okay, now what I do, I see which is the minimum. So 1.79 falls into cluster 1. Cluster 1. Okay, then cluster 3, which is minimum. So cluster 1. Then cluster 3. Then cluster 3. Then cluster 2. Then cluster 3. Then cluster 2. Cluster 2. Okay, then cluster 2. Okay, then I check. Okay, so these are my clusters. Then I check. Have my data moved? Have my data moved? C1, 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 C1. C3, C1, C3, C1. C3, 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 C3. Okay? C2, C3. C2, C3. But if you look at this point, this is C3. Okay, 9th data point C3. But now my data point has moved from C3 to C2. It has moved from C3 to C2. So if any one data points have moved from one cluster to another cluster, again we need to calculate the new centroid. Again we need to calculate the new centroid. So now when I calculate the new centroid, so I do take the mean of the various clusters, of the similar clusters. So again I take the mean C1, C1, C1. Okay, C1. So 4 plus 2 plus 2 divided by 3. And then 4 plus 6 plus 7 divided by 3. I get this. So the same way for C2, the same way for C3, the same way for C3. Now these three will be my new centroids. My new centroids. Can you see? So centroid means what? I am trying to put the circle. I am trying to make the circle as close to the data points, so that it does not move and it falls within the range. It falls within the range. Okay, so now again I calculate the values. After calculating the values, take the minimum distance. So I get these values. Then again I compare. Okay, so if I see the 5th data point, so the 5th data point, that is 1, 2, 3, 4, 5. So can you see 8, 3. What was here? Cluster 3. Now 8, 3 has moved to cluster 2. So again I calculate the new centroid. When I calculate the new centroid, can you see? It has changed. So these are my new centroids. Then in iteration 4, I do the same process. Again I do the same process in iteration 4. Again I do the same process and I calculate the distance. Okay, after calculating the distance, I take the minimum value. Okay, I take the minimum value. Now if you see this one, the fourth data point. So it has moved from C1 to C3. C1 to C3. It has moved from C1 to C3. Okay. So for that, again, because since there is a data point shift, it has moved from C1 to C3. Again, I calculate the new centroid. So these are my new centroid values. Then I shift it to last iteration. Let's see whether there is a change or what. So these are my points. These are my new centroids. Okay. So again, I calculate the distance. I calculate the minimum values. I put them into the cluster based on these minimum values. And then what do? So now I compare C1, C3, C3, C2, C3, C1, C1, C3, C3, C2, C3, C2, C3, C2, C2, C3, C2. So now the previous iteration and the current iteration, there is no shift in the cluster data points. There is no shift into the data points. So since there is no movement of the data points, these are my final positions. So these data points belong to the particular cluster. So when you look at this, these are my clusters. So this is my cluster 2, 6, 2, 4. Okay, 2, 6 and 2, 4. This is my cluster 1. This is my cluster 2. And these are my cluster 3. Okay, so now I have written whatever in k-means student, the algorithm for stopping. Okay, whatever I have explained evenly, I have written there. Randomly choose k points. Okay, so k means it depends on the what value of k you are setting. Randomly we are assigning how many clusters. Means for the each cluster of every iteration we are taking the mean of it and we are doing the clustering. But that's what the k mean is. Okay, so I have written so much of theory part, strength, weaknesses. You can go through it. Okay. So everything is in very simple words, but I have explained you the main concept. Okay, so this is what it has been doing. Okay, so pick the seeds, reassign the clusters, compute the centroids, if there is a difference, okay, and reassign the clusters. This is for the first iteration, and compute reassign the centers. Till when you will be converged? Till there is a difference. There is no difference between the previous iteration and the current iteration. But say for example, minimum 2 iterations you need to do. But in the second iteration itself, if there is no difference between iteration 1 and iteration 2, you can stop. Is this very clear, students? Is this very clear to everybody?
Yes, sir.
Is this very clear to everybody? Okay. Students, I will teach you one more thing and then we'll wind up, students. Kindly please spare another 5 minutes or 8 minutes of your time. Kindly please. Okay. Nearest neighboring clusters, students. Now what I'm going to do, students, I have my 8 data points. Okay, and I have my threshold also. A threshold I'm setting it as 4 for this one. Okay, now students, I'm going to create a cluster. Okay, I'm going to create a clusters. Okay, and I'm going to put them into these clusters. Okay, of all these data points based on the nearest neighboring cluster. Now, the part is very simple. Kindly please understand. Okay, now the first data point, student, I am storing. Since I am starting with my first data point, it will automatically be put into a particular cluster. Okay, that's a direct one. So put A1 into K1. Okay, this is my cluster, say for example, into cluster 1, and directly I will put A1 because it's a starting point. A1 into K1. Okay, now student, I am going to see A2. I will be comparing it with respect to A1, the distance between A2 to A1 using Euclidean distance. So now what is the Euclidean distance formula? We know x2 minus x1 the whole squared plus y2 minus y1 the whole squared. Okay, so now we are talking about the data point A2. data point A2. So 2 minus 2, the whole squared is 0. Then 5 minus 10, the whole squared is 5 squared, which is 25. Square root of 25 is, okay, square root of 25 is 5. Now I am going to check. Okay, square root of 25 is 5. I am going to check whether this 5 is greater than threshold. Okay, if it is greater than threshold, if it is greater than threshold, I will create a new cluster. Say for example K2, and I will put this particular data point into another cluster, which is A2. Can you see, students? I have put into another cluster A2. So A1 is placed in another cluster, A2 is placed in another cluster. Now I am going to take data point A3. Now I will be comparing the data points with respect to distance between A1 and the distance between A2. Distance between A1 and the distance between A2. Okay, so now A3. So now when I do the Euclidean distance between A3 to A1, I am getting 8.48. I will get 8.48. Okay, now when I do the Euclidean distance, that is x2 minus x1 the whole squared plus y2 minus y1 the whole squared, I get the value 6.08. 6.08. Okay, 6.08. Both are greater than threshold. But which is the least? Which is the least, student? This is the least. This is the least. So, and it is greater than threshold, that is 6.08 is greater than threshold, So I will be putting it into another cluster. So A3. So into the cluster A3. Okay, students. Now A4. I will be comparing it with respect to A4 to A1. A4 Euclidean distance to A2, A4 with respect to A3. So when I do A4 with respect to A1, I get 3.605. Then A4 with respect to A2, I get 5.196. A4 with respect to A3. I get 5 point something. Okay, 5. Okay, that is 25. I get A4 with respect to A3. I get 5. Now, so this is the least, right? So 3 is less than threshold, right? 3 is less than threshold, which is 4. And where is this one? A1. Where is A1? A1 belongs to which cluster? K. So I will be putting this A4 into first cluster. Why? Because A4, I am compared with A1, A2 and A3. So out of these 3, this is the least, and out of this list, it is also less than the threshold, and A1 is already in cluster 1, so it belongs to this A4 nearest data point is, its nearest neighbor is A1, so it will go to K1 cluster. The same way, with respect to A5, I will be comparing it with A1, A2, A3 and A4. Okay, so I get A5 with respect to A1, I get square root of 50. A5 with respect to A2, I get square root of 25. A5 with respect to A3, I get square root of 2. And A5 with respect to A4, I get square root of 13 when I do Euclidean distance. So square root of 2. So A3, I get square root of 2. So definitely which is less than threshold. So A3 is in, it goes to the nearest data point is A3. So A3 is in which cluster? K3. So A5 goes to this bucket, this cluster. So I do the same way I do for A6 with respect to A1, A6 with respect to A2, A6 with respect to A3, A6 with respect to A4, and A6 with respect to A5. So A3 is the closest. Okay, so 2 I get. So A3 is the closest. So A3 belongs to cluster 3. So A6 goes here. In this cluster. Now Now A7, I will be comparing it with respect to 1, 2, 3, 4, 5 and 6. In that, which is the nearest is, okay, 10. See, these are all square roots of 10, sorry. These are all square root of 10. When you do, this is square root of 2. This is square root of 2. This is square root of 10, okay? This is square root of 10. Kindly please make a note of it. Okay, when you do, you get square root of 10. So square root of 10 is less than t, which is 4. Okay, which is 4. So this will go to A7. A7 is the closest point, A2 is the closest point. So A2 is already in K2. So it will go to this cluster. The last one, A8. So A8 belongs to which cluster? A8 I will be doing with respect to A1 to A7. So when I do the Euclidean distance, I get square root of 2. This is square root of 2. Okay, so which is less than t? Which is less than t? Which is less than t? So which it goes to A4 is closest is A4. So A4 belongs to which cluster already? A4 belongs to which cluster? Here, belongs to K1. So it will go to this one. So at the end of all the iterations, at the end of all the data points, so A3, 5 and 6 belongs to cluster 3, 2 and 7 belongs to cluster 2, and 1, 4 and 8 belongs to cluster 1. This is how it is, okay? So these 3 clusters, these 3 data points. Once again. Okay, have you people understood, students? Have you people understood? Hello, have you people understood? Hello? How many of you are able to understand? Kindly please put it in chat box and leave. Kindly please put it in the chat box and leave.